Hello everyone, it's May the 17th. I kind of got back into the habit of doing this late at night. Uh, life happens, and then you don't always have time in the morning, and then sometimes I feel like at night is not that bad. It's kind of you're compromised, right? Mind is compromised after a whole day of work, so if I can still perform well, then that will be a big boost to the confidence. All right, anyway, May 17th, let's take a look what we have today. The longest string chain, okay. Given the list of words, each consists of English lowercase letters. Let's say word 1 is a precursor of word 2 if and only if we can add exactly one letter anywhere in word 1 to make it equal to word 2. So ABC is a predecessor of ABAC. Anywhere we can add exactly one letter anywhere in word 1 to make it equal to word would 2. So we add anywhere, okay? A word chain is a sequence of words with k is larger or equal to 1, where word 1 is predecessor of word 2, 2 is predecessor of word 3, and so on. Return the longest possible length of a word chain with the words chosen from the given list of words. So the longest such chain, I think that's B, BA, BCA, that's 3. Oh, any. And it doesn't have to be consecutive. Wait, does it have to be consecutive? No. Just the longest possible with the words chosen. So just the longest. ABA, BCA, BDCA, right? But it has to be one after the other, and then we are adding, right? Every time we're adding, so we will increase in. So we say XB, XBC, CXBC, PCXBC, and PCXBCF, right? Of 2 hints, okay. So a word chain is always increasing because every time you have to add a letter to it, right? That's a clue. Another clue is, so we can sort it based on the size first, right? We can sort it based on the size first. Not really size first, we just put it into groups. Like size 2, we have a group. Size 3, we have a group, right? Size 4, we have a group. Basically, the longest will be because the longest any given word list can be is from the smallest to from the shortest to the longest. Each you take one, right? Because you have to add exactly one letter. So we take we group them together based on their size, right? Group them together based on the size. Can we do group by something like that? Probably not. I mean, we can read through, check the length, and then put it into its position in probably in a dictionary. Yeah, so I think a dictionary, and then right, we try just to figure out. I mean, it has to be consecutive. The length of the words has to be consecutive, right? 1, 2, 3, 4, 2, 3, 4, 5. Doesn't matter. So we're gonna check the first one as 1. We'll have a bunch of them. What about 1,000 words? We have a bunch of them on length 1. And then for each one of them, we can pick one from length 2, right? What if I have many picks? Oh man, if I have many picks, like we have length 1, we have bunch, right? Length 2, we have bunch. line 3, we have punch all the way down. And then we have to see like if it's possible that we pick one from length 1, and then among length 2, we need to find the one that fits length 1, right? And once we find it, then we go to length 3, we'll find one that fits. And then we'll go to length 4. And if there's no length 5, if it is skip, then we cannot do. And we record and we start new. And then we have to start new on the next length. And we keep going until we reach the end. Reach the end, reach the longest, right? Reach the longest. Not really reach the end. It depends. Like if it's segmented, right? It's segmented. We can. If it is segmented, we can. It's possible that we just run separate DFS, right? Separate DFS. Or maybe we can go. Yeah, it has to. Maybe we can do BFS, right? So for each one, right? For each one, we check the next. So whichever one is possible, we record it. We push those in, right? And then, if nothing is possible, then we don't push anything in. If there is something possible, we push into the queue for the next one, and then pop out. So all of these are possible. So I want to see if they're possible to reach the next level. So at each level, we push in everything that is possible to be reached by the previous level. And I shouldn't say that. I'm at the current level, right? I'm at a current level, and I take out each individual string. And then I compare these string with the next level. And if any of these can be formed by to follow this chain rule, right? If it does follow the chain rule, then I will push that into the queue. So they will keep going. So eventually, we just see how far we can progress, right? How far we can progress in this. So let's say we progress into 3. On the 3rd level, we're good. And on 3rd level, we find a few, and then we want to go to the 4th level. But there's no 4th level, right? So the 4th level, it does not exist. Then we stop. We stop, we record, and then we go back up. Now let's say we're going to try the 4th. That 4th level doesn't exist, so we're going to try the 5th level, right? So that's how we want it to be. Okay, it makes sense. How are you going to count? I mean, I can use a counter. Each one, we can turn that into a counter. And once we turn that into a counter, and I basically have 2 counters. I think I can do counter minus counter. Counter minus counter. Yes, I think I can do counter minus counter. Can we? Can we not? I think we can. Right? A from collections port counter. Yeah. So A equals, let's say, BCA, right? B equals BDCA. And then A equals counter A. B equals counter B. Right? A is this, B is this. So A minus B. And B minus A. The larger. Yeah, so B not so anything minus, if B minus A, it needs to return a counter that has only length of 1, right? Length b minus a, the length 1, and b minus a, actually b minus a dot what? Keys, right? So I think I need a it's the values. So it's the values, and then we take the length. So length is 1, and values, I think I can not subscriptable. How do we, because it has to be one letter, right? I think I can do b minus a. I can do a listed. I turn that into a list. Yeah, I turn that into a list. And then if, let's say, counter AABB, right? And then we turn this into a list. That's going to be, oh, the list will, no. Turn that into a dict, right? What would be the best way to know that there's only one letter difference? Well, there definitely is only one letter difference. Oh yeah, there definitely is only one letter difference because I'm only one letter longer than you, right? So if I do the minus and it came out, but what if I have like A, right? I still need to check. Okay. I think it's fine. We can check, right? We can check. We just do minus b minus a, then we get a dictionary, and we'll get a counter, and then we count the counter. The counter is 1, right? That means it's one extra letter. I think that's fine. I mean, what other cases are you worried about? Like repeats? Repeats will work. I think repeats will work as, yeah, so if we do a counter, that's going to be 1. It's only when, like, say, they're not, right? They're not, then, oh, I don't think this works. No, this doesn't work. This one will pass, but it cannot pass. How? This seems to be a very simple question, right? Very simple. How do you determine that it's been like only one letter has been added? Well, we'll just say if two counters, right? We have two counters. We just need to go through the counter. In this case, so we say can we do like this? Like we reverse it? Yeah, look at this. What's the counter arithmetic? I forgot. Counter arithmetic. I don't know if that's the best way to go forward. Operations counter. I don't know. Is this the best way forward, or there are other methods to basically detect, right? To detect how things are. I mean, what I can do, I have a string, right? Return the string into a counter, and then another string, we just go through the counter. Yeah, we can plus, subtract. Counts of common elements are subtracted from each other. intersection and union. I mean, I don't understand. This is so B comma out is 1, and A, that's 1A, that's 3 A's. How is 3 A's? I know it's not going to be negative. I have to read the documentation on this. Counter. I think it does have most common subtract. Or from another mapping, blah blah blah, subtract counts instead of placing them. This is a subtract, not a direct arithmetic. Maybe we can do the keep only positive counts. But I have the A. C minus. Yeah, it has the A. I don't understand. So it keeps the positive count. Less. Okay, so maybe we can say counter AB minus. Because a minus, that's a different operator. There we go. So the idea is if I do this and it gives me something, that means there is some letter that's in the smaller one, but it's not in the big one. And that's a no-no, right? That's a no-no. So a smaller one has to be contained completely in the big one, which means if it's AA, like it's completely contained, then it should return empty. Yes, I think that is the way to go. We'll have a smaller one, smaller counter, minus the bigger counter. If the bigger counter is in the chain of the smaller one, then the result shall be 0. But we have to do the other way around as well, right? We have to do the other way around as well, because the other way around we'll see. So one way, this way tells us that the bigger value does contain, no, that's it, because the bigger value only one letter more than the smaller value. So if we do a small counter minus a bigger counter and then we get nothing out, that means the bigger counter must contain the small counter and that's one letter more. So that means it's in the chain. Yes, so that's actually good. I think we can start writing something. I think I'm ready to tackle this problem. Okay, so here's what we think that can happen. First of all, we do not need deck, right? So, oh, that's not what I want. Anyway, we're gonna use counter. Oh. Okay, and then we're gonna use DFS. So we're gonna go through the entire thing. So we're gonna say that's actually like a graph. Let's call it graph. It's going to be this, right? I'm gonna say for word in words, right? In graph. Oh, that is going to be a default dict. Right, so we go to graph. What did you do? I have no clue. I type 8G because I want to do this. So it's going to be default dict, a list, right? So we say graph dot append what? graph something dot append, graph len w dot append counter w, right? So this turns the entire thing into a graph. And then we say q equals this, and and uh, and the length, right? The level. Level when I start with 1 because as low as is 1. Therefore, this is actually going to be graph 1, and it's going to be empty, which is fine. Which is fine. So, how do we go? How do we go? So we're going to say actually the starting is not going to be 1. The starting is going to be the minimum. So I'm going to say the minimum on graph dot keys, right? And then the q going to be graph, graph level, right? And it's while q, and temp is going to be this. Then we're going to say for counter, right? So for counter in Q, each counter comes out and we also know it's level, right? We know it's level. And then we're going to say if level plus 1 is not in graph, right? If level plus 1 not in graph, then the result res equals 0. And what we want is the longest, right? So if that's 0 and level plus 1, so the level is the current longest. Actually, no, we need a starting level and a current level, right? So level, that's the current level. Then we also need a starting level, which is start level, and just start, and the level equals there, right? And then we say level minus start plus 1. Current level minus start. Like if I level 3 and I started 1, 3 minus 1 plus 1, yes, so it's res equals max res and this. Right? That's if level plus 1 is not in graph, so the level is currently the deepest. Then we update the res. And right after we update the res, we're going to say start equals level plus 1, and q, right, equals graph level, and then we break, right? We break. Actually, no, temp equals this, then we break. Because after we get outside, we're gonna do q equals temp. That's what we're gonna do when we get outside. So that's if it's not in graph, so we break. If it is in graph, right, if it is inside, then we're gonna look through everything. So we're gonna have to be another loop. We say for next C in graph, graph what? Graph level plus 1. Right? The next level in graph plus 1. And level plus 1. Then what do? We check every NC and we say if C minus NC, right? If not C minus NC, that means NC is good. That was a temp.append NC next counter. So go through all that, go to the next, go through all that, and then when we get out, Q equals temp, keep going, and then eventually at the last level, right, the level plus 1, oh, we need to do level plus 1 no matter what, right? Hold on. Let's see. When breakout, I think this one can actually happen later, right? Because we're gonna do level plus 1 no matter what, right? Level plus 1 no matter what. So once we finish the current queue, either because of breakout or because we go through everything, right? When we come out of it, then we say if temp. Actually, not if temp, because we can do else. So we have a break, right? Hold on. A break. I'm gonna handle here. No, I don't. I want to handle this one myself because the break is so if we do else, that's when we finish the queue, right? We go through everything in the queue, and what do? We level into increment 1 and Q equals temp. If we do this, it's going to be level plus 1, and temp will be something different. So we can actually just queue directly. So I think this is actually possible to just say if temp first of all, level gonna have 2 plus equal 1 no matter what. If temp, that means we go through something, we add something, then Q equals temp. Else, if not temp, then Q will equal scruff. Oh, shoot, depend. It could be like I could skip multiple, right? I could skip multiple. Here it's just like one level and it's nothing. Then we count the next level, go back in. If it's nothing, right? If it's nothing, what happens if it's nothing? Depend on temp. Like it's nothing. Like if there's no temp, that means the current level is the end level. Yes. Hold on. I think I have a better idea. We're gonna start from here, right? And then when we go in for C and Q, right? For C and Q, we basically we don't care about this one, right? We don't care about this one. This might be useful. We'll use this one sometime later, but we don't care about these. We just say for C and Q and for NC in this, if not, see this, temp.append NC, right? So this basically is the next temp. And after we get this, we need to check, right? We need to check if temp is good, and the temp could be empty. if temp is empty, if not temp, right? If not temp, temp is empty, which means from my current to my next, there's nothing. So we just update the rest, right? Update rest, and then it also depends on whether we have any queue in it, right? If we it depends if we have queue in it. If our queue is also empty, like if it's empty queue, right? So if not temp and not queue, then we don't worry about it. It has to be if queue and not temp, right? If queue and not temp, that means we have the queue level, but we don't have the temp, we don't have the next level, so that's the end. Then we do this, right? And that's it. I mean, there are no other situations that we should consider, because if there's no queue, then we don't have a current level. We don't even consider. So after this done, we're gonna increment the level. So level go to the next level, and queue equals temp. Doesn't matter, regardless, right? Regardless, queue is going to be temp. So coming back up, oh, queue cannot be temp because we have holy moly, that's not going to be while queue. That's going to be while level is smaller equal to max graph.keys, right? Max graph.keys. And because we only have 16, words.length is 16, so I think we can do it this way. So it's going to be like this, and every time we queue, coming back up, and a new temp, trying to figure out how much temp we have, and then we have a queue but we have no temp, which means we end right now, so we update the result, and eventually the last one, level plus 1, so that's the last level. Last level is all good, and then go up level, and then level, actually we need to be slightly bigger, right? It has to be slightly bigger, the one bigger, so we can afford to just end like this, and we're going to return rest directly. And I believe this one actually can be written like this, right? For C in queue, for NC in graph, level plus 1, if not C minus NC, and then we say NC going to be here, right? So if Q and not temp, gotta do this. Otherwise we don't bother. We go to the next one. I'll go to the next one. Actually, going to be start equals level plus 1. Right? That's how it is, because we need to record the new start. And then, okay, not sure. I mean, it's kind of fuzzy. I felt a little bit fuzzy right now. Not 100% sure what happened, but let's try. Let's see what we got. So we have what, 2 test cases for us to try. Let's see how it goes. So apparently we have a lot of change to make. All of them has to be, oh nope. There we go. And we have all the commas. Well, actually two too much comma, so we have to go like this, right? And then comma here. Now that's going to be words. It's going to be longest chain words. Run it. Result 1. Result 1. That's not what we want. Right? That's not. So yeah, normally it doesn't work. Normally it has to take a few try to get it to work. All right, so 1, 2, 3, 4. All right, we have 1, 2, 3, 4. That is correct. That is correct. Now we're gonna also take a look at here, right? So we're gonna print our level, and actually we're gonna print it later. Level and temp. Right? So current level. Hold a sec. Where's the level? Huh? I don't see. Oh, I think. There we go. Let's hide hidden. 1, 2, 3, 4, 5, 6. Okay, level is 1. A temp is AB and AB. Oh, I have 2 ABs. Ah, we do have 2 ABs. That's true. That is true. I don't think it's possible to. We only need 1. Let's push in the index. Yeah, let's push in the index. Right? So it's gonna be for C and Q, and for I this in numerate. Right? Let's do enumerate. And then we don't push NC, we push only I, push I into it. Temp is going to be I. And this is also going to be, Q is not going to be this. Q is just going to be list, right? List, range, len, this. That's what the Q is. And for J in Q, actually, and then this is going to be graph level J, right? So we have, now we have this, and it's possible for us to get a temp, right? To get temp into a to what? Into a set. Into a set. We'll turn it into a set, right? So temp, we turn into a set. That's good. So temp is a set, and then Q can be a set too, right? It's possible. Q can be a set. Q can be a list. Q can be a set. Actually, we're gonna just call it set. Doesn't really matter. Right? It doesn't really matter. It can be a set, and then we can iterate through a set. Yes, we can iterate through a set. Set of Q, and not temp. Actually, we just say the second value has to be BA, right? If Q, we have Q and not temp. Now we have temp, so we don't do it. So start and level equals level plus 1. Going back up. Going back up. Going back up. And then Q equals temp. Right? Q equals temp. Now going back up. Q basically is this thing, right? This thing. temp is going to be for J and Q is just 0. It's just this thing. No, just this thing, right? Just this thing. For J and Q, for I, and the next level will be these two, right? These two. And what we say is both works. Yes, both works. Okay, so now we go back, and then to the third level, right? Third level coming out is equal to third level coming out is BDCA. BDCA. Oh, I don't know. I mean, yeah, I feel it. It's a little bit slow. I can't think fast. This is level 3. Yeah, level 3. I print level 3. Temp, I still have it. So now start level be 4. Right? 4. And then coming up, 4 level plus 1 is a no. So temp now becomes no. Level 4, temp is no. So we have a Q. Yes. I didn't pop anything. So we have Q. But we don't have this. So we're going to be maximum res level minus start. Oh, because I do start every single time. That's why it's not happening. Start has to be equal to level, right? Start has to equal to level. And why am I going for 6? Largest is 4. I should start at 5. I don't understand. Graph.keys. I'll worry about this later. So it's only when this happens, right? And we'll calculate the res. And then start can equal to level plus 1, right? And then coming out, level plus equal 1. So they both go to the next level. Now we pass, but we still have a 6. How does that come to pass? Graph.keys is 4, right? That's 4. And we can allow to have a 5. If we have a 5, then no, we have a 4. We're currently at 4, right? We're at level is smaller equal to 4. And then the 5 doesn't work. So the compute is from self. Okay, I don't think we need to plus 1, right? But why is level this is weird. Max graph.keys. Yeah, max graph.keys is 4. And level starts 1. How can I print level here and give me level 5? What the heck? What the heck is wrong? Hey, wait, how? How? It doesn't make any sense. What if I do 4? It just like something is changing. The graph is changing. How could a graph be changing? I'm not affecting the graph at all. 4, 4, 4, 4. And now comes to 5. How? How the graph becomes bigger? What did the graph do? I don't understand. Yeah, look, it has a 5 to it. Oh, I think I know because of this. It enumerates, so it does. Ah, ay. So we'll have to do it somewhere else. So max level going to be this. And then it's going to be max level. Now we end at 4. Okay. No, not you. You. We do this one. Both pass. Let's give this a shot. See what we get. Okay. Submit. Pending. Judging. Wrong answer. Ooh, I kind of don't want to see what is the wrong answer. I have no idea what the wrong answer is. I don't know. What could be the wrong answer? Edge cases. Always try the edge case. Okay, edge case pass. What about this edge case? Okay. Let's start from here and no, like this. Right? Just trying things. Let's see. I say this is 3. It's not valid type of string. Oh, I guess you have to use double quotes. I always forgot. I think you have to use double quotes. I mean, not 100% sure, but I do think you have to use double quotes. Interesting. What is the issue? That shouldn't change. Doesn't change anything. Maybe it's the missing. Right? But let's try this and then also try the missing. Means we just delete this. Yeah. And then this is the missing case. What is the error that I accumulate? I don't know. Let's say miss this, right? And then we have this, right? This. Can we capture? That's going to be 1, 1, 2, 3, 4. There we go. There we go. It should be 4. I thought I took into consideration this one. All right? Temp is going to be nothing because nothing's here, so temp is nothing. So Q and not, right? So res is going to be 1, right? And then start, start is, because level plus 1 has nothing. Start is not level plus 1. No, no, no. Start is not level plus 1 because level plus 1 is nothing. Start has to be, man, it's fine. It's fine. Start is level plus 1. We do want it to be level plus 1, right? So start level plus 1, level also level plus 1, and then we go back. Now we go back. Temp is going to be, the Q is nothing, right? We don't have Q. So immediate jump out, so not Q. So we just level plus 1. So the start actually doesn't change. Right? The start doesn't actually change. Start's stuck. And then I would expect it is wrong. Yeah, I can see that there's issue in it. Hold up. Hold. So we do this. This give us 4. Right? This should be give us 4. I feel like we're almost there. Just got a little bit, man, like rusty on this. Right? Yeah, my result is 1. Let's print it out. Just be sure that we know exactly what we're doing. Right? Oh, it's all empty set. Everything is empty set. Everything is empty set. How would everything be empty set? I think it's the Q. Q equals temp. Right? Q never, and I never got this. I mean, we have in total 1,000. How about we just go through every single one of them? I mean, if we go through every single one, but we still need Q, so we need to know, right? Q, we have to have Q. It's just when, not temp, right? So that means the next level, we have no temp. Therefore, we're going to reset like this, right? If Q and not temp. If Q but not temp, so we don't have a next one. Then we set the next one, we set Q equals to the next one. Otherwise will be, we have Q have temp, now we just, if we have temp, we'll make it Q just equals temp. Perfect. If we don't have temp, we don't have Q, and Q still going to be equal. So it depends on temp, right? We say Q equals temp if temp, else if we don't have temp. So that has to be set range len graph level. Now we have 5. Okay, that's also not correct. Nope. What's, actually I don't know. What's set range 0? That's empty set, yeah. If we have temp, then Q equals temp. If we don't have temp, right? If we don't have temp, then level plus 1, we say level plus 1. And we compute the len. So the first one, the temp is empty, right? So that's fine. So we have Q, and now then the rest is 1. Level plus 1, level becomes 2. And then we don't have temp. So we go to level 2, which is an empty set. So coming back up, because Q is empty, so this one's empty. So we've got level 2 is all empty. That's fine. And Q is already empty, right? So Q is empty. So we don't do this. We just level plus equal to 1. Aha, this is the problem. If not temp, then we need to update. If also not Q, if not temp, that means we shouldn't update anything. So let me say if not temp, that's when we need to update the next. And we say if Q, right? If we have Q, then we can update the rest. And start must be level plus 1. And no matter what, level is going to update. Now we pass. Right? Now we pass. Now we pass them all. So basically the change is this doesn't change, right? So like none of these has changed. What does change is if we don't have temp, that means the next level is nothing. So if we have the Q, we have the current level, that means we at least walk towards that. We walk towards the end, so we can produce a result. And afterwards, and then if we don't have a Q, that means we don't have a result. And we say whenever we don't have a temp, so we have like the temp is current the next level, we don't have it, so we always put the starting in there as well, and the level and keep incrementing. And for the Q, so if it's a temp, then if temp has been produced, then it's a temp. If there's no temp, then we need to grab the graph at the level, like we'll grab it directly. Okay, why don't you use the? Why did you use the index? Because of the set. Okay, give it a shot. We have a wrong answer again. All right, I'm gonna take a look at the wrong answer. What is this? What is nonsense? This seems to be a very straightforward test case. How does that one fail? Should be 2, right? Because AAB, BAB. Oh, shit. Order. Order. I didn't realize a counter doesn't take into consideration order. Man. Well, length is 16. I think we are back just to do a straight comparison. Lord, this is not good. Yeah, we have to do a straight up comparison. Like, yeah, like BAC and AB, they are not, right? Because we add at any position, it doesn't give you the new one. How do we do it? there simple way of do it? How? Well, let me see. We have the order, and we want to know if the other value means, like, if we take one letter out, right? We take one letter out and then see if it fits. That's very brute force. I have 16 letters, right? Maximum is 16 letters. So what? Like for each, we just take one out, compare the rest, and if it match, then we say it's good. If it doesn't match, then we say it's bad. That feels ridiculously stupid. All right, ridiculously stupid. I definitely don't like it at all. I mean, we can do is, no, that's also not right, because if you do counter minus counter, what you get is the odd one, right? Odd one out, but you don't know where it is. So you still cannot do the comparison. Ah, Lord. This is, it gotta be an easier way. I mean, we can run substring. Yes. Yes, we run the maximum, the longest common substring, right? The length of the LCS. We run the length of LCS, which is O(n) squared, I think. This one is also O(n) squared. So it's okay. Let's bite the bullet. Let's bite the bullet. Let's write a silly function called def is chain, word 1 and word 2. And word 1 is going to be shorter than word 2. So what we're going to do is for I in range word 2, right? And then we say if w1 equal to w2 to I and plus w2 I plus 1, right? So we cut out I. We cut out I. If this is this, then we're going to return true, right? Otherwise, we're going to return false. Okay, brute force. But here, then there's no graph, right? There's no graph. Like we don't need to do graph at all. We just append W, right? Append word. And then land. These are all the same. These are the same. J and Q for I word. Enumerate this. If we're just going to call the function, right? So the function is going to be self dot is chain. I forgot self. So W1 is going to be the smaller one. So it's going to be I graph level I and W. No, that's J because Q is J. So if it's true, then we get I, and then otherwise we don't get anything. Okay? So handle a little bit of this. Okay, try it. Can now be interpreted as integer for I in range. Where did I say that? Which line? For line 8. For I in range lan. I pass everything now. Okay, try it again. It's a pretty stupid way to detect, but I think because the length is short, so I think it should be fine, right? All right, submit the third try. A charm, a charm. It is still not a charm. Oh my god. Oh my god. Output 6, expected 7. This is not gonna look nice. This is gonna be very, very not nice. Wait, are we going through majority of the test cases? Yeah, we're going through quite a few. Must be some edge case we failed to identify. That's fine. Let's take a look. Now we are already at this trial and error stage, which means it's already pretty bad. So it's fine. We just keep working on it. The goal becomes to try to figure it out, right? Try to figure out what actually went wrong. Okay, so I think we'll do the same thing. Print this graph out. So for key value in graph.items, print key value. And after we've done this, I'm going to print level and temp. Alright, so this is how it looks like. Okay, this is not going to work. We have to go for key in sorted, right? And key in sorted, it's going to be keys. Now we're going to key and graph. Okay, so now we have from small to large, okay? So start with 2. So we can do this, yeah, 0, 1. Now 3. Now at 3, we're looking 4. 4 give us 1 and 2. Right? 1 and 2. Good. Now looking at 4, I'm going to, well, at 4 we take a look at 5. So at 4 we only have 1 and 2. So on 5, what we have is, I just realized, we could have, there could be a situation where we restart. 2, 3, 4, 5, 6, 7. Yeah, that's the thing. We restart. So we are now only at these 2. And then we go here, here, here. That's it. Right? 1, 2, 3, 4, 5, 6. But if we restart, holy moly. Yep, I see the problem. I think it's salvageable. So we have to go through, we have to attach the starting to every value. Okay, so the start, we have the current level, that's fine. We have the current level, but the Q needs to change. Q has to be a set, right? And then what does a set look like? It's going to be for I in range, len, graph level, and it is going to be a tuple level and I, right? So level and I, and then so maximum level. Now we're going to go for 2 things, right? And everybody has a different, everyone has a different starting point. Yeah, so we have, it's going to be a start, into st, and j, right? St and j in q, by doubling this. If self.dot is chain. Actually, no. Mm-mm, mm-mm, mm-mm. Nope, 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 nope. Every single one will be consider everyone else, and then we're gonna inherit. Right, we're gonna inherit the starting position, and whenever a value fails to find anything, and then we can yes. Oh, we're gonna redo this. Redo it. So what are our current queue, right? We'll push this one out, and then we take a look at the next one. Right, we take a look at the next one. So we take a look at the next one, and then we're trying to find out uh, the next. How do I incorporate the thing that's not in there? If I do a list, right? I have my current level and I have everything else, right? So when I go through this, go through each level, when I go through each level, what we want to see is if a certain value has been, is that a start or it has already been seen already, right? So we go through the current level, right? And then we have a starting level for every one of them. And we try to see the next one, right? And the next one, we have another thing. The starting value, the starting position is changed. What if this, instead of a W, we push two things. We push the starting, right? This is going to be the starting. Yeah, this is going to be the starting level. This is your starting level. And this, right? And goes this. And the Q is just going to be I, right? Q is just going to be I. So let's stay with just a range, right? Just a set for the range, which is fine, right? That's just a Q. And then this one might be slightly more complicated. So we get the Q out, so J is out, and then if graph level J, and that's actually not. Yeah, so I think it has to be, hold on. So for each level, right, for each level we get everyone out, and I will try to see if I can go with the next one. So we need to, hold on. What do we need to do? For everyone in the queue, there's no such a thing as a queue, right? That's not a queue. That is like current at, right? I have current at here, and then we look the next one. The next one we can find, and we're gonna inherit my starting position. If the next one does not have, then we don't inherit. And then we compute the current level. So there's actually no queue. We're just gonna go level by level. I think there's no queue. There's no queue. So we're just gonna go level by level, right? We just say for level in range sorted graph dot keys, right? So level by level. Each level, we're gonna see if we can find the next level, all right? We're gonna say, for starting point, and the word in graph level, right? Graph level. And then I'm going to say if the next level is empty, right? If level plus 1 is not in graph, then rest can equal to max rest the current level minus the start plus 1, right? Straightforward. Else, if level plus 1 not in graph, then I have to do this for every single one of them. Else level plus 1 is in the graph. Then we're going to go through level plus 1, right? We're going to go through level plus 1 to find out which one I can do. So we're going to say for j in range graph len graph level plus 1, right? So just in the next level, if self dot is chain w is the current word, and graph level plus 1 j, right? If it's a chain, then we say graph level plus 1 0 equal to starting point. We extend the current starting point to the next level, right? And then that's it. Now we go to the next level. And then everybody's looking for the next one, everybody's looking for the next one until we're done. Then we can return rest. Okay? Try it. We have error, list object cannot be interpreted as integer. Okay, what is wrong? Where? For level in range. For level in range sorted. Yeah, like this. Okay, that's not correct. Your result is 1. How? So start and graph level, that's the starting level, right? So start and a word. If level plus 1 is 3, is in, so we'll go here. Then for j in range, this self.chain w is ks, graph level plus 1, j, yeah, with this one. Then graph level plus 1, that's not 0, that's going to be j and 0 equals st. That's still not right. Anyway, after we've done this, every time we've done it, I think I want to take a look, see what we have done after a level, right? So it'll be a lot of this. So first one is this, second one is not changing. It did not change. This one shall change, right? We never enter here. Oh, I know. Because why don't you throw an error? This has to be 1. Wow. Do you see how long it takes? It took a while. Took a while. So I'm not sure this might time out. I don't know. Maybe, maybe not. We run the entire thing. Oh, we also have an error. What? What is this? So this become a 1, right? And then next one. So just 1. So if level plus 1 not is in, and put j in this. If chain this, then I extend. If the chain is not, if it's not, then I think if it's not, I mean, if this is not, right? Because these two are not, then I don't do anything, right? I don't do anything. I should do something. I think this one changed to 1. And then go to the next one. I didn't update anything. So now we go to the next one. Then it's going to be 3 and BAC. And that's not. Level should be 3 minus 3. That's 1. Oh yeah, that's 1. Yeah, okay. So that's because every time if I fail, then if I fail, then I shall update as well. Right? Because if I fail, I shall update. Not in graph. I mean, we can do this as well. For this, not this, I'll do it. Anyway, let's take a look. Don't print it out. Okay, now we pass all these. Let's try it again. I have a bad feeling about timeout. This is honestly, I don't think it's smart at all. It's very brute force. Yeah, but brute force still got it wrong. What the hell? Wow, I'm not good today. Today is pretty bad. It's pretty bad. Pretty bad. I thought I was okay. Wow, it's 1 hour 24 minutes already. Like how? What the hell? What in the world? Answers for A, B, ABC. No, A, B, D, right? How do we go? So we have A. Probably need to print. Yeah, let's print this each level. So at the end, at the beginning, it's fine. At the beginning, yeah. Print this at the beginning, and probably also need some print some marker, right? To mark. All right. So we start from here, and then A can go to here, so that turns it 1, 1. That's still 2. Now this is now correct. From AB, we can go to ABC. Oh no, I haven't done it yet. This is the next level. A we can go to ABC. From AB, we can go to ABD. I know. This is going to be the min. Yeah, I know what's wrong. It has to be the min, this, and this. There we go. Now we pass. This one shall be right. Sincerely, I think this one shall be correct. Okay, I'll just trial and error. It's the most ridiculous way, but sometimes, you got stuck somewhere. It's the only way to go for. All right, try it again. Pending, judging, pass. I don't even dare looking at the runtime. It's probably very bad. Ugh. Yeah, runtime's terrible. But we did solve it, so that's a plus. I mean, there are two pieces that I think will affect runtime, right? This piece definitely is not helping runtime. And we're going through every single one of them. That's also not helping runtime at all. But we have to consider, right? We have to consider, like, if only a few of them have been chosen, and then the other one we don't consider, that's not true, because we're gonna run into issues. See, it's like 3-4 levels, right? Oof. It's all in tripled. And actually we have one more level nested inside. It's pretty bad. The runtime is bad, so we have to take a look at the official solution. So this is a pure brute force, right? Brute force solution. We first turn words into a dictionary with keys being the length of each word. Then we go from low length to high length. We in the dict, we also record the starting level, right? The starting level that can reach each word. And during level traversal, I just call level. During level traversal, if a word at the current level finds a word in the next level that can be changed. We update the starting level of the next level word if its starting level is not smaller than the new update. This way, we keep the starting value of each word the smallest possible. We update the result either when there is no next level or a word cannot find its, oh my god, I think I know how to solve this. It's a try. You build a try, then you count the deepest of a try. Something like that. Maybe a word cannot find its next chain. So I think this is like ON because level, I don't know what level is. So we say it's going to be total number of levels, right? And then this is ON squared. Yeah, we'll call it OLN squared. I don't even know what this is. 952 milliseconds, or 16% ranking. That's pretty bad. Pretty awful. Awful solution. Okay, so the good ones, right? What is the good solution? Well, the good solution I was thinking about, maybe we can do it like a try, right? I think given this, can we build a try out of it? I'm looking at the first test case, right? So we say B gonna be BA. No, try, that's not how you do try. And BA, BCA. You cannot do try because that's gonna be BC. We split. Because it's not predicted where. Let's look at the solution. I don't want to think anymore. It's getting late. I really want to sleep. It's 11:18. All right, let's take a look. It's a medium question. It took me so long. Recursion plus memoization. Okay, memoization this thing. L squared times n. Maximum possible length. I think I got it wrong. So bottom up. dp. Okay, so word 1 is a predecessor, blah blah blah. Word 2 can be yeah. For a particular word to have more than one predecessor in a given list. Lists belong to more than one word sequence. Yeah, I just consider this list, the immediate predecessor A, B, C, D are this, this, and this. As all these words are missing exactly one letter from the word. True? The predecessor of this is this, and yeah. So we're not familiar with DFS. Here we work backwards to find the longest chain. We start from a word and delete one character at a time. We continue this chain until we come across a word that is not present in the list or is one letter long. So we have this, then we delete one. We see if it's in it. If it's not in it, then we don't go through. If it's in it, then we will go through. And then we also keep go through until the end. That will be the longest. Can be part of more than one word. For example, AB to B is part of both sequence. Yeah. So every time we calculate AB to B, we explore the path. When encountering a new word, we will find all possible sequences with this word as the last word in the sequence. Then we will store the length of the longest possible sequence that ends with this word. Not for the sequence. It's key. So that's the memorization, right? So when we hit AB, and we say we already know the longest, like going from AB down. So if we hit it again, we immediately know. Okay. Makes sense. Makes sense. Yeah, we can code this up, I think. How about bottom up? Adding one other. That's kind of my solution. Adding one letter up. We know the previous length of the longest word sequence that ends with a word. We can use this value to find the length of the longest word sequence for its successor. Okay, the length of the words increases, so we move from left to right. Also, we know that the order of the words in the list doesn't matter, so we can sort the words in ascending order based on their length, iterate over the sorted list, and calculate the length of the longest sequence possible where the word at I is the end word. We store this result in a map. Key is the word and value is the sequence length. By doing this, we ensure that for each word that we encounter, we already know the result of all its possible predecessors. Ah, okay. I see how this one's going. So every word we find, we look for the predecessor. Yeah, I think that is the right solution. I have mine. I'll turn this into a graph, kind of a graph. Just go row by row. But it just, I feel. It took me a long time. Yeah. Now I see it. This is a dynamic program. No question about it. Zero doubt. This is a dynamic programming. Let's code it up and call it a day. That's how fast you can code it up. Well, we have all the test cases, so it shouldn't be too hard, man. So basically, we do need a DP like this, right? And then we're gonna say for how do you know which word is starting? We can save time if we know if that's the starting word, right? So what we're gonna say is, actually I don't know. Sorted word, right? Sorted words equals sort. That's the words dot sort, right? key equals lambda word length word, right? So we can also call min length equals length words 0, right? We say for wording words, if length words equals min length, then dp word equals 1, right? Else then we have a word that we need to split up, which is else for I in range word pre equals w to I plus wi plus 1 to the end, so we delete 1, right? And we say what do we say? We can actually say default dict int, right? And then we say what? We say dp w equals, we're gonna find a minimum from the maximum, right? Max dp this and dp pre plus 1, because I have to add myself, right? So we find each one, each predecessor, and we'll look into the dp to find any maximum, right? Maximum. So after we're done, we go through all that. We're done. And we're going to return. What do we return? Well, we return the maximum of dp dot values. Okay. Now try solution 2. For range len word pass. So dp solution is really nice. The dp solution, the bottom-up dp solution. From official solution. Very nice and quite standardized. Quite standard DP thinking. For each word, we find all of its possible predecessors and look into the DP table to see the max number, the longest max length of chain ending at the predecessor, right? Ending at the predecessor. For each word, we find all of its possible predecessors and look into the DP table to see the max length of the chain ending at the predecessor. We pick the largest of the max length plus 1 and then store in the DP table for the current word. Yeah. I would say for each word, we'll go through all of its predecessors. So each word will go on as word, and when you go to its predecessors, so it's L. So it's going to be, I think it's O, nl squared. And I'm pretty sure this should be ONL squared as well. Actually, I'm not sure. So I think n is the number of words, L is the length of word. Okay, let's see how fast this one runs. Definitely looks better, right? Wow, look at this. Oh my goodness. So much better. Oh wow. This is ridiculously better. 24 milliseconds. Yeah, I think this is not right. This is probably longer, much longer. Let's give us 90% ranking. Jeez. Okay. Yeah, that's about it. DP solution. Huh? DP solution. Jesus. Get blah blah +1 for I. And this maximum to give to this. Oh yeah. Oh, and ONLN for sorting. ONSS for loop. Man, just these lines. Unbelievable. What should I say? It's just don't say anything. Don't say anything. Yeah, it's pretty bad actually. It's we shall be able to solve this faster. I mean, it took us way too long to solve. But I mean, at the end of the day, we did solve it, and so yeah, I guess that's the most important. Yeah, I think that because we start with a wrong idea. I forgot. Like it's a string. I have ordering. I thought there's no order. Yeah, that's why we got stuck. We waste a lot of time at the beginning. Anyway, that'll be it for today. I'll see you guys tomorrow. Adios.